Now that you know what a structure is like, I'm now going to compare that with a class. So we're going to move into object-oriented programming. Let me explain this little cartoon I have here. C++ actually started off as being C, and the C programming language is just procedural programming language. It doesn't contain any objects whatsoever. So C++ takes the basics of C and then added object-oriented programming to it. So that's why C++ is saying to C, you have no class. So an object which is created from a class consists of data plus operations that can be performed on that data. So for example, if I were going to create a planet class, then I could create a planet object. And that planet object could have data such as temperature or distance from sun, and then could have operations such as get the distance from the sun or get the temperature of the planet. I have several different examples to show that objects are created from classes, but this is a cookie cutter, and you see these cookies are created from the cookie cutter. So objects are created from a class. Here are these pictures again, so you can see the difference between a structure and a class. So a class is a beefed up structure. A structure has data members, where a class has data members, but also function members. Whenever you create a structure, you create a structure variable, such as dog, my dog, or dog, dog array, and create a 100-element dog array. Whenever you have a class declaration, you can then create objects, which are also called instances from a class. So dog, my dog, or dog, dog array. Notice that this looks identical as far as creating the variables, but my dog, that is an object, is a lot different from my dog, that is a structure, because it's a lot more robust. A class is like a blueprint, and objects are like houses built from the blueprint. Let's say that this green box is an object of a class, and we have our data members, which are these blue circles. You need to learn this vocabulary. Attributes are our data members of our class, and the member functions are called member functions. All of these are members, both the attributes and the functions. Encapsulation is an object-oriented term that means combining data and member functions into an object and making sure to hide the data. Data or information hiding is very important in object-oriented programming in order to protect the data. So the way that we do that is we make sure that our attributes are private, meaning that it's hidden from outside code. The only functions that can access these data members or these attributes are the member functions that also are members of this class. Then outside code can access those data members, but only through calling the member functions of the class. A real-world program is never written by just one person. So every program you've written so far in this class, you've been using objects that other programmers created, such as cin, cout, and string. The reason why I'm talking about this is because object reusability is one of the best reasons of using object-oriented programming. So that once you create a class, you can then use that class by creating objects in your code in many different programs. Let's say that I owned this awesome car, and all I need to know in order to drive this car is just its interface. I need to know how to open the door to get in, how to turn on the car, how to use the steering wheel, the gear shift, the gas pedal, brake, ignition, and mirrors. I don't necessarily have to know about the catalytic converter, how to change spark plugs, about the engine, or anything like that that's under the hood. In order to drive the car, I only need to know the things that are meant for me to be able to drive, the interface. In the same way, a programmer should separate an object's interface from its implementation. The user of an object only needs to know the interface. In other words, if we go back to this image, this outside code is using this object, and the interface are these two member functions that the outside code is calling. Here's the syntax of a class. It looks exactly like a struct, except we have the word class instead of struct. Then the class name, which should always start with a capital letter. Beginning curly brace, all the members, which are going to include our data members attributes and our member functions. Then the ending curly brace and a semicolon. So this is called a class declaration. Here is a class declaration for the book class. I have data members or attributes, and I have member functions. Notice that the member functions are function prototypes, not actual function definitions. After I define this class, I can then create an object or an instance of the class in my outside code. Basically, outside code is any source file where you would include the header file that contains the class declaration, and then you can create an object of that class. So I'm creating a book object here called my favorite book. And then I can access the data members. Sorry, take that back. I can't access the data members because they are hidden. I can access the public member functions by the dot operator and then the name of the function. The way that we do data hiding in a class is that we use access specifiers. Access specifier. We have a private access specifier, which is a keyword that allows the user to disallow. Okay, so it allows the programmer, not the user, to disallow direct access to all members declared after this specifier. So the attributes, num pages, title, and price are all private. Then the public access specifier will allow direct access to all members declared after this specifier. So what's public? The set num pages and get num pages functions. Notice the access specifiers always have a colon right after the specifier. Some notes about access specifiers, they can be listed in any order in a class. So I can put public first and then private. You can also have multiple access specifiers throughout a class. So I could have private, public throughout the class. If you forget to put any access specifiers in your class, the entire class will be private and therefore not usable. So you will definitely want to have some kind of interface, public interface for your class so that you can use your class and create objects. Now, you've seen that these are function prototypes, so that means that the function definitions have to be defined somewhere. The programmer defines the details of each member function in the class implementation. Class implementation is a separate file, which is a source file, that is named the exact same thing as the class. I'll show you an example of that in a few minutes. So this is the set num pages function, and I want to point out a few things. First, notice that we have to say what class this function belongs to. We do that by putting the name of the class and then a scope resolution operator. The scope resolution operator is 2 colons, and you've seen this before. For example, you've seen this whenever we open a file in a particular mode by doing iOS : app for append mode, or in for in mode, input file mode, or out for output file mode. But here we are setting the scope of this function, saying the scope of this function is the book class. That's what it belongs to. Also, I want to point out in the getNumPages function, you might have noticed, back up again, that it has the word const in the function prototype. What this means is I have defined this function as a constant function. Const informs the compiler that this function will not be modifying the values of any of the attributes. So instead, all this function is going to do is return the value that's inside of an attribute, but not actually make any changes to it. Okay, I just went into my example programs folder and the objects and classes folder. You might notice that I have a lot of separate files in here. What we're going to pay attention to first is the oop.cpp file. So I'm going to open up my command prompt and open up VS Code in this directory. The oop.cpp file contains a class declaration plus all the class member functions plus outside code all in one file. This is atypical. Normally you're going to have several different files for all of this stuff. But just so I can show you in one example, this defines the book class. Here's my attributes. Here's my member function prototypes. Here are my function definitions. And then here is my main function that actually creates a book. And then I set the book name to the giver. And then I print out the book name by calling the getBookName function. This is not going to be very impressive when I run this program, but I'm going to show it to you anyway. oop.cpp. All that happens is I print out the giver to the screen. It seems pretty silly to have all this code just to print that out to the screen, but this is just for demonstration purposes. I also want to show you that if I were to try to access book name, which is one of my attributes, directly through my book object, I'm not going to be able to do that. You see the red squiggly line, and it tells me that book name is inaccessible. I always like to look at what the compiler says in comparison to this. oop.cpp. So the compiler says error on line 39. Book name is private within this context. So it gives a little bit better detail on what the problem is. And then it tells me also the name of the attribute that's private here, and it puts it in red and highlights it. Then it also tells me line 9, it says declared private here. So if we look at line 9, that's where I have defined book name, and it is under the private access specifier. So that just shows you what the data hiding aspect of object-oriented programming is. We are protecting that. And this allows the programmer to only allow outside code to access the data in the way that the programmer intended.